Hello students, welcome all. So today we are going to discuss about basic coordinate geometry which will be used in problems, right? So let us start basic coordinate geometry. Basic coordinate geometry. So I will not go more into detail about that we will be sending the notes, but here we will see just the basic which you may be knowing but important formulas. So in coordinate geometry, you know there is x, y, positive, negative, right? This is negative y, this is negative x. Now any point, if you take any point, let's take, if I am taking 2 dimension, this is 2 dimension, I am taking 2D, 2 dimension plane. So here any point will have x coordinate, y coordinate. What is x coordinate? X coordinate is nothing but the distance of this point from y axis. This distance, this is x. And what is y coordinate? Y coordinate is distance from x axis, perpendicular distance, right? So this is y. So you can say this is x and this is y. Okay. X is also known as abscissa, and y is also known as ordinate. Okay, so any point in this plane can be represented by pair of these two numbers. Any point, and in the first quadrant, you know, both are positive. Second quadrant, x is negative, y is positive. Third quadrant, both are negative. Fourth quadrant, x is positive, y is negative, right? So this is very basic. Now here, how to calculate the distance between any two point and the distance of a point from origin. So if you take this point, let's say in general this is point P, origin is 0, 0. So if you join them like this distance OP, which you can represent as R, this R can be given as root under x square plus y square, right? This will be the formula, or this will be the distance of a point from origin. Okay, distance of a point from origin. Now we'll see distance formula. In distance formula, distance between two points. Okay, distance formula. So if there is point A and there is point B, and this is x1 comma y1, this is x2 comma y2, then when you join them like this distance AB can be calculated as root under x2 minus x1 whole square plus y2 minus y1 whole square. And this is nothing but, you can also write this is delta x square plus delta y square. It is the change in x, right? The x has got changed, so delta x square and delta y square. This distance we can calculate. Okay, right. Next, now we can also calculate area of a triangle. A triangle area can be calculated if you know 3 points coordinate. Suppose this is a triangle ABC, and you know the points x1 comma y1, x2 comma y2, x3 comma y3. If you know this, right, you can calculate the area of the triangles formed by joining these lines, right? These points, if you join, you will be making a triangle. What will be the area of the triangle? Area of triangle ABC. So area of triangle ABC can be calculated as keep x1 and then you can take y1, y2 minus y3 plus keep x2, you can take y3 minus y1 plus keep x3, you can take y1 minus y2. Okay, So if you keep x1, then y2 minus y3. If you keep x2, then y3 minus y1. If you keep x3, then it is y1 minus y2. It is going in a cyclic order, and the magnitude of this you have to calculate, and then you have to divide it by 2. Okay. After calculating this magnitude, you have to divide it by 2, and this can also be represented as half of, in matrix form, that means in matrix calculations in maths, it can be also represented as half of x1 y1 1, x2 y2 1, and x3 y3 1. Okay, matrix form. So this way we can solve it. Okay, area of the triangle. Then section formula. Section formula. What is section formula? So suppose there is a line and there are two formulas in there, which is internal division and external division. So suppose there are 2 points, points A and B, and their coordinates are given x1 comma y1, x2 comma y2. Let's say a point P which is in between. It means in between means in the line joining AB, but in between. Between it can be anywhere, and let's say this divide it in the ratio m is to n. Right? M is to n ratio. This so point P coordinate can be calculated. Let's say point coordinate P is x comma y. So x can be given as m x2 plus n x1 by m plus n. Similarly, y can be given as m y2 plus n y1 by m plus n. And let's say the ratio is terms of k is to 1, because here if you introduce m and there are two things which may be given. If they are not given, let's say this ratio between them AB, this point P, this ratio is k is to 1. Okay, k is to 1, and this is the line joining pattern. The coordinates of A and B are given. This is x1 comma y1 and this is x2 comma y2. So this x comma y can be calculated as k x2 plus x1 by k plus 1. Similarly, y coordinate will be calculated as k y2 plus y1 by k plus 1. Okay, this is better because you have to just take k is to 1. Sometimes it is m is to n. If it is given, then you can take that. Okay, this is for internal division. Okay, point dividing internally. Okay, internal division. Now there can be a case where there is external division. Let's take external division. External division. So let us take point A, B, right? Coordinates is x1 comma y1 and x2 comma y2. So externally means if you join this line AB, point will be outside this line. That means you can take the point P here. Okay, this is the point P, and AB, AP is to BP. This ratio will be m is to n. So m is to n ratio. Okay, so in that case, similar approach, the point P coordinates x comma y can be calculated. X will be m x2 minus n x1 by m minus n. Similarly, y will be m y2 minus n y1 by m minus n. And in case if the ratio is taken as k is to 1, like if you take this ratio as k is to 1, this point A and this point B, this point is P. Okay, it's the same straight line they are lying. Okay, so if the ratio is taken at that, then x1 y1, let's say this is a x2 y2, and this point P is x comma y. So then x can be given as kx2 minus x1 by k minus 1, and y will be given as ky2 minus y1 by k minus 1. Okay, so using this approach we can solve coordinates. Okay, similarly midpoint coordinate and the coordinate of the center of a triangle, centroid. Let's see that. Okay, so suppose if you have been given a line AB, and if you take x1 comma y1 and x2 comma y2, and if you want to find the coordinate of the midpoint P is here midpoint. So this is just the average. X will be x1 plus x2 by 2, y will be y1 plus y2 by 2. Okay, P is nothing but it is the midpoint. Okay, similarly if there is a triangle, let's say triangle ABC, and the coordinates are x1 comma y1, x2 comma y2, x3 comma y3. Then the centroid is generally denoted by G. So the centroid G coordinate can be calculated as x coordinate will be x1 plus y1 plus x1 plus x2 plus x3 by 3. X coordinate, y coordinate is y1 plus y2 plus y3 by 3. This is how we will calculate x coordinate and y coordinate. Okay, right. So these are some of the basic informations which can be used in the calculation. Now this is 2-dimension geometry. If it is 3-dimension, then how do we do? In 3-dimension there will be x, y, z also, right? Those things also will be there. But in 2-dimension, these are the things. In 2 dimensions there are other things like a straight line and a circle and many other things. So let us first discuss 2 dimensions, something more. So in 2D geometry, let's take equation of a line first. We will see line, circle, ellipse, right, parabola. So what is line? So line, if you draw the xy coordinate axis, you can draw a line like this. So in general, the equation of a line is written as ax plus by plus c is equal to 0. This is the general equation. Okay, but if we want a specific equation, that means in terms of particular things, then we can write. So let us say different forms of equation we can take. Let's say this equation y is equal to mx plus c. This equation is in terms of slope. This is the slope and this is intercept. So this is called slope intercept form. This is slope intercept form. So in slope intercept form, this y equal to mx. What is m? Suppose if this is angle theta, so m is nothing but tan theta. And here c refers to y intercept. Okay, c refers to y intercept. Okay, this is one form, slope intercept form. It's an important form. Any equation can be converted in this term, right? And intercept can be negative also. It can cut to the negative y-axis. Okay, then what other forms of line equation are there? So another form will be 2-point form. 2-point form. What is 2-point form? So suppose in a straight line 2 points are given. Let's say this is x1 y1 and this is x2 y2. Okay, now what you need to do is you need to determine the equation of this. So you can write one point x comma y. This x comma y is a variable. x1, y1, x2, y2 fixed point. Okay, 2 points are given, right? So to write the equation, we'll write y minus y1 is equal to slope. Slope is y2 minus y1 by x2 minus x1, right? This is the slope into x minus x1. So this form is 2-point form, where if you know 2 points, you can find the equation of that. Okay. Similarly, we can have a point and a slope. Okay, point and slope form. So let's take a point here as x1 comma y1, right? And slope is m is the slope. So in general, here also we'll take a point which is x comma y. Then we will write y minus y1 is equal to m, which is slope, x minus x1. Okay, so this way we can write the equation. Then any other form is there? Yes, there are intercept form. That means both intercept x and y is given. Okay, intercepts form. So suppose there is a straight line which is cutting like this. There is a x intercept, let's say a, y intercept is b. Okay, so the equation of this line is x by a plus y by b is equal to 1. This is intercept form. Both the intercept are given, then you can write it. Okay, or you can transform equation in this form, right? Then next equation of a line based on the length of perpendicular. Suppose there is a line like this and you can drop a perpendicular from origin 0, 0. You drop a perpendicular. The length of the perpendicular is p and the alpha is the angle made by the perpendicular or normal. So here tan alpha is slope of normal. Okay, so this form will be equation of line based on normal, length of normal. Okay, length of normal and slope of normal. Okay, slope of normal. So based on this, we can write the equation of this line will be p cos alpha or x cos alpha plus y sin alpha is equal to p. Okay, this is the equation of this line. Okay, normal length of normal, and how to find the length of normal to a equation of a line in general, that also you see. So suppose if there is a line, equation is ax plus by plus equal to 0, and there is a point P whose coordinate is x1 comma y1. So length of normal from a point to a line, or this can be said as distance of point from a line. Distance of a point from a line is given as mod of ax1 plus by1 plus c divided by root under a square plus b square. This is an important formula, distance of a point from a line, and it is used in many calculations. Okay, then let's go to circle. I think circle very basic, about circle, right? So circle general equation will be, suppose the center is x naught y naught and the radius is r. So the general equation is x minus x naught whole square plus y minus y naught whole square is equal to r square. Okay, that's the general equation. And if x naught y naught is origin, the center is origin, then what will be the equation? Then 0 0 it will become, then it will become x square plus y square is equal to r square. Okay, that we can substitute. Then you take parabola. Parabola equation depending on how parabola is oriented. So standard equations you can take. First of all, there can be 4 standard equations based on how the parabola is made. So if you take parabola like this, okay, another parabola like this, another parabola like this, and another parabola like this. So you see in the first 2 cases, first and second, here the axis of the parabola is this x-axis. This is called axis of parabola, right? This is the x-axis of the parabola. This is the axis of parabola. So in the first 2 cases, x-axis is the axis of parabola and the vertex is origin. Origin, if you see, origin is vertex. In all cases, origin is vertex. Okay. So if I have to write the equation of the first parabola, we will write y square is equal to 4ax. And similarly, if I have to write the equation of second, we will be writing y square is equal to minus 4ax. Here we should know what is a. This point a comma 0, here it will be of course minus a comma 0. This point is also known as focus. So focus is f. Let's say if you write f. So f is the focus, it is a comma 0 or minus a comma 0, where x-axis is the axis of parabola. Similarly, if you consider y-axis, here the y-axis is the axis of the parabola. Y-axis is the axis of the parabola. So if y-axis is the axis, then we can write equations in case of third. The equation of parabola will be, instead of x, it will be y. So x square is equal to 4ay. And similarly here in case of fourth one, we can write x square is equal to minus 4ay. These are the standard equations of parabola with origin as vertex. Okay, origin is vertex here also. And the axis is, in third and fourth case, it is the y-axis. But there can be more general equations which may be parallel to this, parallel to x-axis. Axis can be parallel to x-axis or y-axis. In such case, we have to go for a different type of equation. Now let's say in case of parabola, you take, for example, this is how a parabola is, let's say, okay, and the axis is, this is the axis, this is, let's say, parallel to y-axis, okay, and it is bending upward. So the general form is x square is equal to 4ay, but instead of x, the vertex is now something, not 0 0, it's not the origin. So let's say this is x naught comma y naught. Okay, so here also this equation will be x minus x naught square is equal to 4a y minus y naught x square. So the equation is in the form of x square is equal to 4ay, but only thing is capital X is x minus x naught, capital Y is y minus y naught. Okay, and in such case also there is the focus f, and the distance from here will be, so x is not changing, right, y is changing, so this y naught plus a it will become, right, so this will become y naught plus a, where this length between f and this vertex, that distance is what? What is that distance? This distance is nothing but a. Okay, that's the focal length, you can say. Okay, so this way in general you can write for other parabolas also in the same manner. So this is parabola. Then ellipse, if you see ellipse equation in general, it can be again, you know, let's say like this. If you consider origin as vertex 0, 0, and if you take this length as a, this length as b, right? So this equation is x square by a square plus y square by b square is equal to 1. Okay, so here what is a is called semi-major axis length, and what is b? B is called semi-minor axis length. Also important to note here is that b square is equal to a square 1 minus c square. So here that E is called eccentricity, and the value of E is less than 1, greater than 0 and less than 1. Okay, there are other form of ellipse also. Suppose if you take ellipse in the form of like this type of ellipse, so here what will happen is that the major axis length, you can see this is looking smaller than minor axis length. Okay, so here the formula will remain same, x square by a square plus y square by b square is equal to 1, but the only thing is that because a is smaller than b, so here a square is equal to b square 1 minus c square, because eccentricity always remains less than 1. Okay, that's how this equation of ellipse is written. And if the center here, like origin which is 0, 0, this is the center of the ellipse. If the center is different, then you have to replace x minus x naught whole square by a square plus y minus y naught whole square by b square is equal to 1. Here x naught y naught will be then the center of ellipse. Okay, there are many things you will be learning in maths, but this is some very basic that you should know, right? Then what is hyperbola equation? Let's take hyperbola. Hyperbola, if you consider, then it will be like, you know, x-axis, y-axis, and it will be like this. Okay, so this equation is x squared by a square minus y square by b square is equal to 1. This is the equation. Okay, we will not go much detail in that, but one thing you can know is rectangular hyperbola. Rectangular hyperbola equation is x into y is equal to constant. This type of equation is called rectangular hyperbola, and the rectangular hyperbola will look like this in graph, because in physics, in Boyle's law and other places, you will be seeing its application. So it will be like a graph like this, or it can be negative this side also. Okay, but if the variables are positive, you will see only the positive side. Okay, right, this is what it is. And more details, all these things you will be studying in maths. Okay, so with this I think it's over, but in some time 3-dimensional geometry, they may not ask in physics more application of 3-dimension, but you can note about 3D coordinate geometry also. 3D coordinate geometry. If 3D coordinate geometry is taken, that means there will be x, y, z, everything will be there, and this is the origin 0, 0, 0, right? So any point if you see, it will have x, y, z. All the 3 coordinates will be there. right? So in 3 dimension, this point will be making different angles with x-axis, with y-axis, with z-axis. Suppose it makes angle alpha with x, beta with y, and gamma with z. So we can calculate the length of this, right? OP can be calculated as root under x square plus y square plus z square. Length or distance of point from origin, right? Similarly, you can also calculate direction ratios, okay, or direction cosines. So cos alpha can be calculated as x by this distance, which is you can take as r. Cos beta is y by r, and cos gamma is z by r. And cos square alpha plus cos square beta plus cos square gamma is going to be 1. These cos are called direction cosines because it is giving direction, okay, direction cosines. Direction cosines means this cos alpha, cos beta, cos gamma, okay. And sometimes this cos alpha is written by the symbol L, cos beta is written by M, cos gamma is written by M, right? So here there is no such thing like slope, but these ratios cos alpha is to cos beta is to cos gamma, or L is to M is to N. This is called direction ratios. Direction ratio. So these direction ratios act like, slope. It acts like a slope in 2-dimensional geometry, right? Similarly, if there is a line, then what is the general equation of a line in 3 dimension? In 3 dimension also there will be equations of line which you can. So what is the equation of a line in 3 dimension? Suppose this is a line in 3 dimension, and let's take any point here as x0, y0, z0. So one point is given, and let's say x as any arbitrary point x, y, z. Then x minus x0 divided by L is equal to y minus y0 divided by M is z minus z0 divided by N is going to be constant, or some k is constant here, okay. This is how equation of a line can be given in 3 dimensions, okay. Similarly, if you consider a plane, then equation of a plane, this is a plane, right? So equation of a plane will be given as ax plus by plus cz is equal to 0. This is equation of a plane. Then very complex things can be there, but right now we don't have to see that. And distance of a point, let's say x0, y0, z0 from a plane, this distance can be calculated as, this distance is, let's say, p, so this length p can be calculated as ax0 plus by0 plus cz0 divided by the root under a square plus b square plus c square, okay, like this. And here some other factor can also be there. For example, this side it can be plus d also, it doesn't matter, okay. Some constant can be also there. So like that we can solve questions. I think 2-dimension, 3-dimension geometry, this much is sufficient. Anything extra while solving problem, we'll come to know. Thank you for your attention.